The concept of stack is plotted as last in, first out. Some of the literatures, they mention it last in, first out instead of stack. In this chapter, we are going to discuss about the abstract data type. So you already know about the abstract data type when we learn about the object-oriented. And yeah, we are going to learn some examples about the stack. And yeah, there are some also another example to see that how stack can optimize the complexities. Last in, first out. People may say it as LIFO. Okay. L means last, I means in, F means first, O means out. So we call it this last in, first out. Let's see what we can learn from this stack. In every data structure, we will notice about abstract data types. And I will just use ADT. ADT, abstract data type, is an abstraction of a data structure. I guess you still remember abstraction. So we want to build a kind of blueprint of a data structure, and we can implement this one in any problems. We can implement it in the problem of, for example, some application in the stock, or you can also implement this data structure in the other application, such as on the marketing and etc. Okay. So the ADT, it specifies the data stored and operations on the data and error conditions associated with operations. I guess this is the concept of object-oriented programming, okay, OOP. We will have the data, what kind of data that we are going to use, and what are the operations. So the operations means the methods. And we need to give the condition of the errors. If the operation is not appropriate to some condition, then it shows the error message. Okay. So the ADT modeling can be implemented, for example, in the simple stock trading system. The simple stock trading system means, in the stock, we will do buy and sell. We will buy stock or we will sell stock. When we buy, it means we need to know how many stock that we want to buy and how many shares that we have now and what is the price. If we want to sell, it shows the same parameters. Or if you want to cancel, then you can have the cancellation operation. And this one represents the object. Whenever I do order buy, then I will have one object buy. Whenever I do selling, then I have one object sell. And if I want to cancel, I can cancel either buy or sell. So that's why this parameter represents an order. Let's say there might be some kind of error. Then you can define what are the errors. If the stock is not available, so your buy or sell will not be valid. Or some error condition about the cancellation of non-existent order, then it will be also errors. Yeah, those kind of things you can define in the ADT. the stack ADT. The stack ADT, it stores arbitrary objects. Arbitrary means any objects. So you can have, for example, student information, or you can have the information about car. You can have information about buildings, and etc. Insertion and deletions follow the last in first out scheme. So in every data structure, we will learn how to insert, how to put a value into the data structure, and how to delete the data in the data structure. Yeah, this is just an idea. Think of a spring-loaded plate dispenser. This is the spring-loaded plate. So whenever you put one plate, so here is one plate. Whenever you put one plate, then if you put another plate, it will go down. If you put another plate, it will go down. If you put another plate, it will go down. If you put another plate, it will go down. So if I want to get the plate, then I will get from the top. I need to get from the top, and then I need to get the second top. I need to get the third top. I need to get the fourth top, and then I need to get the bottom. So the idea of stack is similar with this kind of spring-loaded. There are two main stack operations. The first is push, and the second is pop. If it is push, it means we are going to put the data into one repository or one kind of container. Let's say this one is the first part. We have the data 1, and then I want to insert another data 2. So I will push 2. I already have 1 and 2. I want to push 3. And yeah, I have 1, 2, 3. If I want to include another data 4, then I want to push, then I have 1, 2, 3, 4. I have another data 5, I want to push, then I have 1, 2, 3, 5. 1, 2, 3, 4, 5. And then if I have 6, then yeah, if I push, I have 1, 2, 3, 4, 5, 6. If I want to pop means I want to remove and returns the last inserted element. Then I will exclude 6 because it is at top. If I want to pop, then it will be the last element, which is 5, because I already removed 6. Until we have only the element number 1. Okay. So the main operations will be only 2. Push, and we insert the object. And the second is pop. We want to remove it. There are some auxiliary stack operation. Auxiliary means addition. We can use top object. Yeah, it depends what is the object. If it is about building, then you will put the object building. Now I want to know the top. It will return the last inserted element without removing it. So I want to know what is the last element. Okay, in this case, if the last element is 6, then it will show 6. Length, it means the how many items or how many elements that you have been stored in the container. And the last is empty. It indicates whether no elements are stored. So it's empty. Usually we want to see whether the container or the repository that we have is empty or not. That's why in the Boolean we have true or false. So this is an example if you want to write it in Python. Let's say I have a kind of repository, and then I start with an S. S is an empty. Let's say I'm using list. Okay. First, I will push 5. Then there is no return value, and the stack content is 5. So 5 is inserted here. So we have the stack content is 5. And if I push 3, then there will be another content, 5 and 3. 5 and 3. And if I want to check length of S, then the return value will be 2. And I have the stack contents 5 and 3. Okay, so it still remain 5 and 3. If I do pop, then the return value will be 3. Why? Because 3 is the top one. So we remove 3. And then the remaining stack will be only 5. If I check S is empty, then it is false. Why? Because I still have 5. So I still have one element. I still have 5. If I do again pop, then the return value will be 5. So we will exclude this one from the stack, and it becomes empty. And then I would like to check S is empty. Yes, it is true, because now there is no element. If I do pop, what happened? It is error. Why error? Because I do not have any element. Okay. If I push 7, then there will be a new element 7 in the stack. If I push 9, then I will give 9 insert into the container. If I want to check what is the top, it will return the value 9, because 9 is at the top of the stack. If I have another element which is 4 and I want to push it, so 4 now is in the top. Yeah, this is the stack content. If I want to check what is the length of S, then it is 3, because we have 3 elements. If I want to pop, then I will exclude 4. I will remove 4, and then it will return the value 4, and the remaining information will be 7 and 9. If I push 6, so I have 6, and the element stack contents will be 7, 9, 6. If I push 8, I have another element which is 8. So the contents will be 7, 9, 6, and 8. If I pop 8, then 8 will be removed. So the last stack contents will be 7, 9, 6. So 7, 9, and 6. Okay. If you can do this step by step, then you will find out about this. If you want to see on the oh sorry, I didn't put this stack here. Okay. Yeah, basically you can also do with this one in the Python. In the application of stack, the direct application is the page visited history in the web browser. If you use the web browser and then if you visit, first you visit Google, and then next you visit Naver, and then next you visit kind of newspaper, then it is a sequence. Or yeah, you can put now the current page is about the newspaper. If you want to remove, then it will go to the next second. If you are using text editor, let's say if you are using Microsoft Word or if you are using Hangul, you have the undo sequence. Undo means the control set is canceling. Undo, you have control X, okay, then it will go to the previous one. What you already did previously, it will be shown. Or it's kind of chain of method calls in a language that support recursion. So if you are using recursion, then you can also use this kind of stack mechanism. Some indirect applications might be about the auxiliary data structures for algorithms. Yeah, later, maybe we will learn about graph. In the graph, you can use stack. Or some other components of other data structures. Let's say if you use tree. So if you use tree, there's also a possibility to combine tree and stack. In the implementation, we can implement stack with array. There's a simple way, yeah, of implementing stack with array. As I show you in the example before, we can use list. If we use list, it means, yeah, it is the simple array. Of course, if you want to apply with array, yeah, you need to define the data type. Let's say if I want to use only integer, then you need to inform the data type, this is I. If you want to use only a float value, then you need to inform F to represent the float value. And we add the elements from left to right. As you know, in the list, yeah, it is starting from index 0, index 1, index 2. So index 0 will be first. And then if you have another new element, it will be in the index 1. If you have new element, it will be index 2. If you have new element, it will be index 3, and so on. And where is the top element? So a variable keeps track of the index of the top element. The top element will be the last index. If you have the length, the length means the number of elements in a list or in an array. And after you know how many elements are there in your array, then you can know the top element will be, yeah, you can just access S, length of S, and you can do with -1 because I want to know based on the number of the array and then -1. The array storing the stack elements may become full. You know, when you are doing with the array, there is a capacity. And if the capacity become full, then when you have a plus operation, will then need to grow the array. So if you still remember, last week we learned about the growable array. There are two kind of growable array. You still remember? There are two growable array. The first is incremental array or incremental strategy. Okay. And the second is the doubling strategy. Okay. This is to see what is the best one if you want to grow the array in the long run. And as you might know from the previous section, when we are growing the array, yeah, we can just copy the elements over. Copy and then grow. Copy and then grow it. Now we can see about the performance. What is the performance and what are the limitations? Let's suppose we have n elements. So n is the number of elements in the stack. As I mentioned to you in the previous section, we will have two kinds of performance. The first is the space performance. The space performance means how many space do we need to save the data in our data structure. And the second is time performance or the complexity performance. In the space performance, because we have n as the number of the data, then we will just say this is On. What about the time complexity? The time or the complexity for its operation, it runs in time O1. And this assume that this is based on the amortized in the case of a push. So if we push, it means we are inserting a new element. And then if we are inserting a new element, then we will check from the beginning until the top. If we have an element, then we are performing On. Okay. Then n divided by n, yeah, it will be 1. Okay. So the amortized time is the Tn, the time that you will run the algorithm divided by the number of the data, which is n. So if it is On divided by n, then it will be 1. So the operation time for each of them, it will be O1. It is based on the amortized time. This is the implementation in the array-based stack in Python. If you check on this, you will see the init is the constructor. Length, it is the method to get how many elements in your data. And then is empty, whether the stack is empty or not. And then you have push. Okay, what is push here? In very simple, if you use list, then push is just calling the method append. So you are appending one value, append one value, append one value. And if you want to see the top, how you can see the top? Yeah, here there's an explanation. It will just return the element at the top of the stack, but do not remove. So I just want to see what is the last element. In this case, yeah, we can use is empty. If it is not empty, then see the element -1. The -1 means the last element. And if it is empty, then you will give raise. Okay. You already learned about raise. Whenever we have an error, and if we do not want to stop the program, then we can just use raise and it will show the error message. The error message here is stack is empty. When we are doing pop, so here is the explanation: remove and return the element from the top of the stack, which is levo. So we will check again whether the stack is empty or not. If it is not empty, then self data.pop. So pop is a function in Python. It is to remove one of the element, and the element that will be removed is in the last element. So if it is empty, then it will go to this race and it will show the error message stack is empty. So this is empty is from this one. Okay, is empty is from this one. If you go to this section, yeah, this is the array stack, and we are just using the very basic data structure, which is this. Okay. Now you can see we have a main method here. In the main method, we are creating an object. So the first object is S, and this object will have the content with an empty list. And after we have this empty list, we want to push 5. Then the content will be added with 5. 3, and then we will add 3. If you want to see what is the length of S, then the output will be 2. If you want to print, when you want to pop, okay, when you remove, then it will remove 3 and the remaining contents will be 5. If you want to check whether it is empty or not, yeah, it will return false because we still have one value. If you have pop, we will remove it, the element, and we will show 5 to be removed and the contents becomes empty. If we want to check is empty, yes, it is true. Now if we push, it means we want to insert a new element, 7. We push 9, we have a new element, 9. If we want to check the top, yeah, we can check this one, top, 9, and so on. Okay. So you can run this code and you will get like this one. Okay. So when you have a problem in Gurum, if you want to show the result, you need to use this statement, print. Whenever you want to show some kind of statement, then yeah, you can use print statement here. Okay, some examples of stack. We can do parenthesis matching. Parenthesis matching means whenever I have a starting bracket or starting parenthesis, there should be a closing, okay? Opening, closing. And the brackets or the parentheses can be 3 different types, whether it is the common bracket or the curly bracket or the square bracket. So I need to check each of them. If it is the general bracket, then yeah, I need to have this general bracket. If I have the curly bracket, I need to have the curly bracket. If I have the square bracket, I need to have the closing. Oops, this is wrong. Sorry. Okay, should be here. It should be the closing one. So you need to check it's of this one. Yeah, this one is correct because we have opening, closing, opening, opening, closing, closing, opening, closing, opening, closing, opening, closing, opening, closing. Okay, so you can see, based on the sequence, and you will see the completeness of the parenthesis. And you can see also this one, whether it is correct or not. And you need to create your algorithm. How to make this algorithm? So let's say this is incorrect because it starts with the closing. This is incorrect because the placement is not appropriate. And then this is incorrect. There is no closing. Then how can we make this algorithm? First, you can have your pseudocode. As you already know, pseudocode is the high expression language for your algorithm. You do not need to have your detail in Python code. You need to just express with the human language, and some of the formula can be removed. So here, when you are making your algorithm, you need to define what is your algorithm name. In this case, we have the name parent match. And we have two parameters, which is x and n. And when you define your algorithm, you need to have two different kind of elements. The first is input. What is the input? And you need to see what is the output. So those two should be available in your algorithm. And you need to define the input because some input may have a very detailed input. For example, here, people will ask, what is x? And people will ask, what is n? So in this case, I will explain that an array x of n tokens, each of which is either a grouping symbol, a variable, or arithmetic operators, or a numbers. And the output, it will be true if and only if all the grouping symbol in x match. In the algorithm creation, you need to consider the input and output like this one. So when you are doing with your team project, I hope that you can also have this kind of format to develop your algorithm. And this is your algorithm start. Let S be an empty stack. And then we will start from 0 until n minus 1. And we are going to check for every of these condition. If the xi is an opening group symbol, then push. If not, then check if it is a closing grouping symbol. If it is not empty for the S, then it is written false. If it is match, if the pop does not match with the type of X, then it also returns false. So if it is empty, then returns true. So it means every in the S or every element in the stack has been removed. So what you can see here, you have the push. So whenever you have the parenthesis, you will push, and whenever you have the correct, elements, you will pop. Okay. You can see from here, we have the left T, which is the general bracket, the curly bracket, and the square bracket, and the right T is the general curly bracket and the square bracket. And you will have one array stack. So I will call the array stack, and then we will do the for loop. If C is in left T, then push. Else if, check if it is in the right T, and then check if it is not empty. If it is empty, then false. And then check if the right T in the index C is not equal to the left T index S pop, then false, because it is mismatch. So if all symbol match, then you will check. If it is empty, then it is true. If it is not empty, then of course it is false. Okay, so this is the very short code to make the parenthesis matching. Maybe first, let's see the code. Here is the code, okay, with the is match. If you run this one, and let's suppose I have this match, I have this element, bracket, 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 and closing, closing, closing. Then the return is true. If I have opening, 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 and closing, closing, so there is one missing closing, and the result is false. Okay. The second example is about HTML. If you understand the web programming, you will need to understand the tag. Okay. When you have the tag, it means there will be opening tag and there will be closing tag. So the idea is the same with the parentheses. There should be opening, closing. If you have like body, this one, there should be closing body. If you have h1 tag, there should be closing h1. If you have center like this one, then there should be closing center. So for fully correct HTML, each of these name should pair with a matching name with slash. So we need to check this one with the HTML matching. Yeah, this is the algorithm. In the HTML, we use the triangle bracket. That's why when we create this one, we will use the triangle bracket. This is the opening. If this one has the opening, and we will check with the closing. So we can find the next character. And if it is already in the last, then false. And then the tag we want to strip away. So we want to check only the triangle bracket. We do not want to check other things. If the tag starts with the slash, then yeah. If not, then it is opening tag. If it is true, then it is the closing tag. If it is empty, then there is nothing to match. So if you can understand this, yeah, you can make the code. So at the end, yeah, we want to check whether it is already pop or not. Okay, so something that you pop is similar with the tag or not. And then if it is not the same, then it is mismatch. Is empty means everything is already popped from the stack. Okay, I think I will stop here.